Welcome to lesson 4 in the quote unquote holiday course of finance. So let's get started. Today we'll be covering investment style annuities. This category comprises of simple annuities, the ones we covered in the previous couple of lessons, where you make multiple deposits, all of which gain compound interest. It's really important to understand that. Okay, so each, you deposit 10,000 in January, 10,000 in February, 10,000 in March, 10,000 in April, and so on and so forth. And then you really want to know, like, each of these $10,000, investments will compound separately. January one is going to compound till the end of the year. The February one will compound till the end of the year. The March one will compound to the end of the year, and so on and so forth. All of them will compound separately, and you just add up the sum of all of these separate investments, multiple separate investments. You add all of these up at the end to get the value, the future value of your annuity. So this is the approach that the syllabus wants us to take. Now, I know we did cover the annuities as a recurrence relation, and I do have a section, method 2, where I cover how to do it using like algebraically treating annuities using a recurrence relation. However, I was looking at the syllabus dot point again earlier today, and I noticed that it says calculate the value of the annuity by developing an expression for the sum of the calculated compounded values of each contribution. So they really want us to, the syllabus at least wants us to look at the compound values of each contribution, and then make a formula for the sum of a geometric sequence from that. So they want us to look at each of these compound values separately, and then make a geometric sequence, a formula for the sum of the geometric sequence. So that's what we're going to be focusing on. I probably will not cover this method 2, but I'll leave it. The text is going to be here if you want to look through it and whatever. And look, we'll cover this anyway because the reducing balance loan stuff, the reducing balance loan, the thing that's coming up that will require algebraic treatment of a recurrence relationship. Anyway, let's just get started. So yeah, I kind of covered the dot point already. So let's have a look. Now, to understand this lesson properly, you really need to make sure you've looked at the previous lessons. Don't underestimate the understanding you will develop from the previous couple of lessons. They're quite important. Okay, let's just have a look. Let's just get started. All right, if $1,200 is invested at the beginning of each year for 5 years at 8% per annum, how much will the annuity be worth at the end of the 5th year? Now, once again, we know this is not a compound interest question because it's saying it's invested at the beginning of each year. You have multiple investments. That's really key. Compound interest, you have one investment only. With an annuity, you have multiple investments. That's the hallmark, as I've been saying over the past couple of lessons. All right, so we're going to start off by drawing a really rough timeline. So you can draw something like this. Let's just say it's really rough. It doesn't have to be too fancy or complicated. Okay, this is where it starts off, right? And then what I'm going to do is I'm going to do this, and we'll do dot, and then we'll do, I don't know, let's say, let's just do this, okay? And let me just make this a tad bit smaller. Right, and the idea is this. Over here, I'm going to write down the time period. So I'm going to write 1 here, 2 here, that's dot, and then, I will write like, now it is for 5 years, so we'll write the 4th and the 5th year, okay? Now this is a timeline of sorts. It's very rough, doesn't matter, it just needs to get the job done, right? And so the way it works is, this is the start of the first year. This is the end of the first year and the start of the second year. This is the end of the second year and the start of the third year. Okay, just make sure you understand that. Now, what we're gonna do is, this is like a graphical depiction of money coming in and money going out. So let's just look at the question and think about, when is the money going to come in? When is the money going to come out? So it says $1,200 is invested at the beginning of each year. So if $1,200 is coming in at the beginning of this year, so we write We'll draw an arrow going into the timeline, and we say $1,200 coming in. And over here as well, it's $1,200 coming in at the beginning of each year. And it'll keep going. Now, at the beginning of the 4th year, what do you think will happen? Yeah, that's right. Another $1,200 will come in. Beginning of the 5th year? Yep, because it's the beginning of every year. Okay, but at the end of the 5th year, no, there's no money coming in at the end of the 5th year, because we want to know how much the annuity will be worth at the end of the 5th year. So at the end of the 5th year is when we're taking the money out, so to speak. That's when we want to know how much is the annuity worth. Okay, so now that we have done this, let's think about, okay, make sure you understand what we have so far. Make sure you understand what we have so far. We have 5 separate transactions. We have 5 separate deposits, 5 separate investments. Because at the beginning of the 1st year, 2nd year, 3rd year, 4th year, and 5th year. That's 5. 5 deposits. We have 5 deposits, okay? So I guess you could say you have 1,200, 1,200. Hang on. You know what? I'll make it a bit more visual. 1,200 here, and you have 1,200 here, and then you have, you know, 1, 2, 3. You have 1,200 here, and then you have 1,200 here. All right. Now, let's think about it, because it has to. Okay, how much will each of these values compound to? We know this is going to be, all of this is going to compound separately, remember. So they're all compound interest questions, so to speak. Each of these deposits will compound separately. So this is going to be, you know, 1 plus, what is the interest rate? 8% per annum. So 8 over 100, right? And really, we want to know how much. And it's going to be 1 plus 8 over 100 as well. How much? And so on and so forth. So, the first one, at the beginning of the 1st year, it goes all the way here, 1, 2, 3, blah, blah, blah. And from the last one, the 5th one, it will also compound once. Okay, hang on a second, let me rephrase that. The first one will compound 5 times. 5 time periods. The first value will compound for 5 time periods. The idea is, anytime the money is in the bank for a year, it compounds once. Okay, so from here to here, it compounds once, because it's compounding per year. Now, that $1,200 has, from the start of the 1st year till the end of the 1st year, it has spent 1 year with the bank or wherever you're investing. And so it will compound once, and then compound again, twice. Okay, and hopefully you can see a pattern that after it's gone through the 2nd year, it's compounded twice. So after it's gone through the 4th year, it will have compounded 4 times. And after it's gone through the 5th year, it will compound 5 times. Okay, so that's really the pattern you should be looking at. Because many of the questions that you'll do, there won't be just 5 time periods, right? It might be like 120 time periods. And then you really want to look at the pattern that's developing. Think about the pattern. Don't try to memorize, you know, rough rules, you know, anytime it's at the end of the year, then it's going to be n-1. Don't do that. Just look at it, draw this timeline, and look, once you get good at it, it will not take long. I'm obviously explaining it and going really slowly, so it's taking me a while, right? But when you do it on your own, and you practice, you'll be fine. It does not take long, I promise. It's very quick. And you just want to look at the pattern. Develop a pattern for yourself. Examine it, look at it carefully. So the first one, the first deposit, it goes, after it's gone to the 1st year, it's compounded once. After it goes to the 2nd year, it's compounded twice. So after it's gone, you know, ... After it's gone through the 4th year, it will have compounded 4 times. And then therefore 5 times. And therefore this over here is going to be 5. And look, the second was just going to be 1 less. It's going to be 4. And we kind of know all of them. We just want to examine the last one now. Okay, the last deposit, it's going to stay in the bank for 1 whole year. Now, it's important to understand it won't always be like that. It will not always be like that. Sometimes you'll actually put money in at the end of the 5th year and take out the money at the end of the 5th year as well. So if that were the case, the money, the $1,200 you put in at the end of the 5th year will not have compounded because it hasn't spent 1 year in the bank. But in this particular question, because you're putting money in at the start of the year, and it will spend 1 year in the bank, and therefore you will get 1 year of compound interest. So this is going to be 1 plus 8 over 100 to the power of 1, because it's going to compound once. Okay, so how do we actually type this up? So this is what we do. Let a underscore n be the amount of money. Oh, hang on a second. Be the let n be the nth investment. Okay, so the first investment, how much will the first investment be? Well, the first investment is going to be 1200, so it'll be 1 plus 8 over 100. And how much will it compound? It will compound 5 times. Okay, and look, we can't just simplify the bracket. So 1 plus 8 over 100 is just 1.08 all to the power of 5. Right, so that's the first one. Now we look at the second one. You know what? I might just... I'll just write it like this. Just so we can see the pattern, because we do want to see a pattern so we can make the sum of GP. You'll see, okay? So now we look at the second, one, the second deposit, the second, it is an annuity, right? Second one will compound for 4 time periods. So it's going to be 1200, 1.08 to the power of 4. Because this is the second investment. How much is going to compound? It's going to compound 4 times. It spends 4 years with the bank, and therefore it compounds 4 times. And we just continue in a similar vein. And, you know, I'll just cut a corner a little bit, just to save time. And that's going to be the third one. That's going to be the fourth one. That's going to be the fifth one. You know, in fact, just so that we can be a bit more realistic with the harder questions, I will not write down the third and fourth one. The idea is you're trying to see a pattern here. You really want to see a pattern. And as a general rule, you know what? I'll make a rule for you. You always want to do the first 2 and the last 2. And I put a dot, dot, dot in the middle. Okay, first 2, last 2, just so you can see a pattern, and then put the dot, dot, dot in the middle. Because sometimes, you know, the questions you get will be fit. Some of the questions will be really hard, and you'll have to do like 120, 240 time periods. You're not going to list all 240 of the deposits, right? That's just not practical. No one wants you to do that. So you see the first 2 values, the first 2 deposits, and the last 2 deposits, and that will be good enough. I'm pretty sure every teacher will accept that. Your HSC will definitely accept it. So now the idea is we want to add all of these up. So the amount total is going to equal to A underscore 5. And I'm going to reverse the order of these, because with the GP you want to start with the small total, right? And you work your way up, because that's how a GP works. Right, you know, you have a common common ratio, and it increases and so on and so forth. It's just personal preference. You don't have to. I'm doing it. Most teachers will tell you to do it as well. The important thing is plus A underscore 3. You know, and like I said earlier, we'll do this A underscore 2 plus A underscore 1. And I know we could have written A3 there. We're not going to write it. We're just practicing for the questions with really large number of deposits. Okay, write the first 2, write the last 2, and put a dot in the middle. So now what I'm going to do is A is equal to, I'm going to sub values in. What was A5 equal to? A5 is that. So I'm going to write it in. Right. I'm going to add to that A4. What was A4? Oh, hey, A4 is this. So I put a dot, and then now I'm going to write A2. What's A2? A2 is here. And look, I am obviously substituting. This is generally what you do in an exam anyway. This is what it means to substitute. Right, where you see A1, you put the value of A1, you copy paste it, so to speak, right? All right, so you have that. Now this is the I guess this is what we've been building up to. This is the core of the topic. we're going to apply series and sequences to finance. That's why this is known as series and finance, obviously. Duh, right? So all first step you want to do is factorize out the common stuff. Factor out the common terms. So A is equal to, and I'm going to do 1200 only. I will not take out the 1.08. You get the exactly the same answer, but I just prefer not to. That's just my personal preference. In my humble experience, I found that students make a lot more silly mistakes when they do factor out the 1.08. I don't know why. Maybe it's just slightly more difficult. I don't know. Look, if your algebra is really good, more than welcome to factorize out the 1.8 as well, because it is common to each of them. It's common to each of them, right? But I prefer not to. Because you get the same answer at the end. You get the same answer. So the A value for the sum of a GP will either be 1 or it'll be 1.08. If you factorize out an extra 1.08, then it'll just be outside the bracket and A will be 1. If you don't factor it out, then A will be 1.08 and there will not be a 1.08 on the outside. I'm sorry if that's confusing, just ignore it. My point is, you get the same answer. And I recommend my students do not factor out the 1.08 to avoid making silly mistakes. Just factor out the 1200. It's pretty simple, it's pretty straightforward. You can't possibly go wrong with that. And 1.08 to the 1, I write the 1 on purpose. 1.08 squared, right, dot, dot, dot. 1.08 4 and 1.08 to the 5. Alright, that's what we have. Now we are going to apply the sum of a GP. Now, hopefully you remember the formula, which is more or less A R to the n minus 1 all over R minus 1. Okay, so that's the formula. Now A is obviously the first value of the GP, and the first value is clearly 1.08. Now R is the common ratio. How much is it going up by? Well, it's clearly multiplying by 1.08 because it's going 1.08 squared, 1.08 to the 4, 1.08 to the 5, and so on and so forth. And that's really all you need. Oh, N is how many different numbers do you have? Well, if you have 1 to 5, you have 5 values. Okay, so let's just apply the formula. Pretty straightforward, right? And we'll write therefore, and we'll do A is equal to, and we'll bracket here. Now we do have 1200, so let's not forget the 1200. All right, on the top of the bracket we'll have A. What is A? It's 1.08, and whoops, and then we have R, which again is 1.08 to the power of 5 of them, minus 1, 1.08 minus 1. All right, and look, just put it in the calculator and you get the answer. That's pretty much it. We're done. So we'll do approximately is equal to, and look, we can do it on the calculator. I'll stop being lazy. So look, we'll do 1200, and then we'll do open bracket 1.08, 1.08 to the power of 5 minus 1 over 1.08 minus 1. And look, I'll type it exactly the way I see it, okay? I'm trying to avoid being lazy. And there we go. That's our answer. 7603.11 roughly. And that's the essence of it. That's pretty much it. That's how it works, okay? I'll just recap what we've done. We drew the first thing we did, we drew a timeline. That's really important, especially if you find this topic confusing. Just draw a timeline, learn how to do it. If you don't know how to do it, the only way you're gonna learn is if you practice. Like that's it. There's no other way to learn maths. You can't watch me do maths and expect to learn maths. Like, you know, maths skills based, kind of like karate. I always use this example. You can watch Jackie Chan or, you know, Bruce Lee or whatever. You can watch them do karate all day long and they look really cool. You'll be very impressed and so on and so forth. But you'll never learn karate that way. You can watch MMA and so on, and you'll never learn how to actually wrestle and, you know, fight and, you know, MMA and stuff. You won't learn until you actually do it. Maths is exactly the same. It's no different. You know, you have to actually do it to get good at it. If you're weak in this topic, Do heaps of questions, for this topic. Convert your weakness to a strength. There's no other way. You can't be weak at a topic and then not do questions and expect to get good at that topic. It doesn't work that way. If you want to get good at something, you gotta do it. Put in heaps of time, you will get good. It's not too complicated, in my humble opinion. It's just a matter of putting in hard work, getting used to it. They're very, very similar. All questions are fairly similar, okay? So we have invest at the beginning of the year. Let's have a look at another question where we are investing at the end of the year. All right, so it's $1,200 to put away at the end of each year for 5 years, 7% per annum. How much will the annuity be worth at the end of 5 years? Once again, we'll draw a timeline, okay? And then we'll do ... All right, so there's going to be 1, 2, ... and 5 years again. So we'll do 4 and we'll do 5. Okay, so now $2,000 is put away at the end of each year. So I'm going to draw the arrow here because at the end of the first year, you're putting in 2,000. And at the end of the second year, you're putting another 2,000. And we do ... We're not really concerned. We just want to find the pattern. Now over here, this is going to be the end of the third year. So obviously there's going to be 2,000 here, right? And there's going to be a 2,000 here because that's the end of the fourth year. And at the end of the fifth year as well. Okay, and when are we taking the money out? At the end of 5 years. Well, at the end of the fifth year, you're also taking, and I'll change the color of my pen. So you're also taking the money out at the end of the fifth year. All right. So once again, this time I'm not going to do any rough working out over here. Let's just go directly from the timeline we've drawn to writing out each investment. So our first investment, what is that? How much will it be? Well, it's definitely 2,000, right? And it's 1 plus 7%, so it's going to be 1.07. And look, if you're doing a more complicated question, make sure you convert the interest rate to the compounding period and end to the compounding period, all that stuff, right? But let's just focus on the annuity section. I don't want to get distracted with the converting interest rates and number of time periods. We did that in compound interest questions. It's exactly the same. It's no different. Let's just focus on the annuities in this particular lesson. Okay, so you have 1.07 to the power of something. How many things? So we look at our timeline and you want to figure out the pattern. That is the key. So at the end of the second year, this has compounded once only. Because how long has that money spent in the bank? 1 year. So at the end of the second year, that amount that we put in at the end of the first year, over here, it's not going to get a compound interest because you just put it in. It hasn't spent time in the bank. You get interest when money spends time in the bank, so to speak, right? It's the price, like I've explained last few lessons. Money has value over time because you can invest money in a business or lend it to someone or whatever, and money, the price of money is interest. That's what we call it, interest. It's like if you own a house, what's the price of a house? Rent. If someone is using your house, they give you rent. If someone's using your money, they give you interest. If you put money in the bank is going to use your money and lend it out to other people. And so when your money spends time in the bank, you get interest, so to speak. So over here, this $2,000 has spent 1 year in the bank at the end of the second year. So it's going to compound once. And then it's going to compound. Now, if you look at the pattern, and the second year, it compounded once. So in the fourth year, it will have compounded 3 times. In the fifth year, it will have compounded 4 times. So over here, I'm going to write to the power of 4. Okay, and now that we have that, the rest of it, falls into place. 1.07 all to the power of 3. And we write ... And then now we're going to do the last 2. So the fourth investment. And let's have a look just in case 1.07 to the power of 1. Well, let's look at the fourth investment. Our fourth investment will have spent time for 1 year only. The fourth investment is at the end of the fourth year. The first investment was at the end of the first year. The fourth investment end of the 4th year, and it spends time for 1 year in the bank. It compounds once only. And so over here, we write compounds once. Oops. And lastly, we have our last investment. This should not be a surprise. 1.07 to the power of 0. Why 0? Because it spends 0 time periods compounding. You put the money in on the same day you're taking the whole investment out. At the end of the 5th year, you put money in, you also take it out. So it doesn't compound because it didn't spend time in the bank. Okay, and there we have it. And now the rest of it is pretty straightforward. A is equal to A, and look, we'll reverse it like same as last time. Dot dot, and we'll write A 2 plus A1, and now we can sub stuff in. So we'll sub this in exactly the same as last time. Sub it in, plus sub that in, and we'll do plus, and we're going to sub A2 in, dot dot dot, and then we will sub the last value in as well. Alright, and now as before, we're going to factorize out the common value, the common term, which over here is 2000, and then we'll have 1.07 to the power of 0 plus 1 dot dot plus dot dot, and it goes up to what? 3 times and then 4 times. All right, now we apply the sum of a GP formula, and A is equal to 2000. So what is going to be our first value? 1.07 to the power of 0. Okay, and you can write 1.07 to the power of 0, or you can write 1. It doesn't matter. You can even not write it at all, because anything to the power of 0 is 1. So you can skip writing it entirely if you so wish. But you know what, just for the sake of completeness, just so we can see where the formula is and so on and so forth, we'll actually write it down. So we'll have 1.07 to the power of 5 again, because there's 5 of them, and we'll do minus 1 all over 1.07 minus 1, and put it in the calculator, and you're done. I mean, you can simplify that if you wish. You don't really need to. You can. If you're good with algebra, go ahead, go for it, right? Like the bottom denominator will be 0.07. 1.07 minus 1 will be 0.07, obviously. But there are no variables in that expression. No variables at all. You can put it directly into your calculator, you'll get the answer. One common mistake I see students make is they forget the 2000. Very common. Because they get so focused on that, they completely forget about what you factorized out. So don't forget that. And yeah, look, just put it in the calculator, and you will see you get something like, so right, approximately equal to, because we are rounding off now, 11,501.48 or so. Yeah, so there we have it. All right, and that's pretty much it. I don't want to confuse anyone, so I'm not going to go through the algebraic method for the time being. We can, you guys can have a look at this after you've done the next lesson, okay? After you've done the next lesson. I was going to cover it, but because the syllabus wants you to explicitly use the method that we've just covered, so I'm just going to cover that. Because in my humble experience, again, when I try to cover too much, students get too confused. So leave it. Don't confuse yourself. If you get what you've done, just start doing investment type questions, master them. And this second method, we're going to cover it anyway when we get to the reducing balance loan thingamajig, like next lesson. And then you can come back and read through it. It's all there, all my working out, all my explanations, everything's there already. I've covered everything. So don't worry, we're not missing out on anything. All right. So the homework. We're gonna stop doing textbook questions now because we don't really need to. This is not new syllabus stuff. This is Yeah, this is not new syllabus stuff. This particular type of question has been around for decades, like probably from 1960s or something. So there's heaps and heaps and heaps of trial paper questions to choose from. And look, I looked through a whole bunch of papers and I found these papers definitely. So the Balcombe Hills trial paper from 2015 definitely has an investment style question, and so on and so forth. All of these papers, they're trial papers, year 12 yearly exam papers, HSC trial papers, and they all have investment style questions which you can learn from. So find them up using Google Fu, ConquerHSC, Google Fu, get it? And so yeah, look at the relevant question, give it a go. They should have worked solutions at the end for you to mark from. If you don't get it, ask on Discord. And if you come across a really hard question, a really weird and unique question, save it. You know, make like a Word document. Make a Word document and save it, because it's very good for revision. It's very good for revision. It'll help you prepare for HSC. Alright, so best of luck. And ask for help on Discord as needed.